Next up is Kevin Lakai, who is a senior software engineer at Spexi Geospatial, a crowdsourced drone imagery company. Kevin uses GIS, computer vision, and photogrammetry to design scalable processing pipelines for that drone imagery. So I'd like to welcome him to the stage now for his presentation.
Thanks, Tyler. Yeah, great presentations, everyone. Also, welcome to the familiar faces in the comments. Yeah, so I'm Kevin, as Tyler said. I'm a senior software engineer at Spexi. We combine drone technology, geospatial software engineering, and computer vision to develop a crowdsourced marketplace for ultra high resolution imagery and photogrammetry. I'm not going to be showing you drone imagery today, but this was inspired off of some work that I do at Spexi. So as you guys know, hobby drones only capture RGB imagery, like you don't have any near IR or any spectral bands. And it can become pretty expensive to do any sort of AI models when you have extremely high resolution imagery at scale. So this is where Fuse inspired me to do this work. I'm going to show you how I used Fuse's platform to build a vegetation segmentation model that operates at global scale without relying on any spectral bands or any AI models. I'm going to share my screen with you guys. Give me a moment. All right, here we go. So accurate vegetation analysis on global scale is kind of a complex task, especially without near-infrared, like I mentioned earlier, since that's essential for calculating indices like NDVI. Near-infrared helps distinguish vegetation more accurately, but it's expensive and not easily accessible for large scales. And when it is, it can be pretty expensive, as some of you guys might know. However, relying on RGB data alone, while more accessible, like drone imagery, for instance, usually lacks precision needed for vegetation analysis. And like I mentioned earlier, training AI models at scale becomes pretty challenging due to the variations in data quality, resolution, and the extensive need for labeled data sets. My goal was to develop a simpler solution for RGB data alone, while enabling a cost-effective real-time analysis that works across different zoom levels without needing for complex models or hard-to-acquire data. So here you can see a UDF I built, nothing special, you just have a bunch of imagery in my backyard near Vancouver. I'm actually not using the base map that Fuse provides. I'm actually using another one from ArcGIS World Imagery base map. And so nothing really special is happening here. I'm just pulling it in and I'm just skipping processing and just presenting it right away. But what I did here is I built a UDF in the background in the modules here to do some sort of vegetation segmentation that relies only on classical computer vision techniques and band math without any sort of machine learning models. So let's just dive into it quickly. I'm not going to go into the details, but as you can see here, there's nothing too special. All pretty basic, simple libraries. We have CV2, so OpenCV for the classical computer vision techniques like morphological operations filtering, and we use like Rasterio for handling the data. So there's no need for any heavy GPU usage, which significantly reduces any costs computationally and speeds up processing. So what this UDF does is it combines a bunch of classical computer vision techniques and band math to pseudo segment this data. Let me show you a quick demo of how this works in the Fused app. Actually, let me undo something first. So I'll quickly show you here how it works. So if I just set the return boolean to true of the mask, you can see that this quickly just segments all of what you saw as vegetation into a mask of vegetation. So using the app, you can see that we use different vegetation indices. So I'm going to mostly focus on VARI today, or Visible Atmospheric Resistance Index. You can see here that that you can also variably change the threshold indices. So this is going to effectively let you change how sensitive you are segmenting the vegetation in the scene. And it does it like instantly. So you can do this vegetation analysis with almost instant feedback, that instant gratification, that instant geospatial insight that you need to do any of this work in real time. And so this project really showcases how you can skip the labeling, you can skip the machine learning models. You can just use simple band math, some easy to use Python packages, and fuse this powerful infrastructure to transform global scale vegetation analysis with just a few clicks. And I think that's all I have time for today. Thanks, guys. You can see more in my blog post over here.
Thanks, Kevin. Just one quick question. How was your experience of actually creating the app, the transformation from your code behind the scenes to actually building the app?
It was remarkably easy. Yeah, the Fuse team made it like super easy. I'm not going to pull open the code because I don't want to get into the weeds of it, but they use some really easy to use open source Python packages to make it just seamless to integrate the UDF to the app. Took maybe 15 minutes.
Great.
Yeah.
All right, thanks. I think we then will transition on to our next presenter. Our next presentation will be from